Hi everyone. In this video, which is the last one in the gas turbine cycle series, we are going to look at how we can improve the thermal efficiency of a gas turbine cycle by using an intercooling and a reheating scheme. So, apart from the regenerative scheme, the other ways to improve the thermal efficiency of a gas turbine cycle are intercooling with multi-stage compressor and reheating with multi-stage turbine. Now, you have already known that if you apply the multi-stage compression, the work required in the compression will be lower than that of a single-stage compression. Similarly, when you apply reheating with multi-stage turbines, you will get more work than that of a single-stage turbine as well. For a complex gas turbine cycle, you can actually combine all efficiency improvement methods, whether it would be a regenerative scheme, an intercooling scheme, or a reheating scheme. You can have all three of them in the same cycle. Now, let's have a look at the shape of such a complex cycle on a TS diagram. In this case, let me start from point 1, which is fresh air. Fresh air enters the first stage compression. It is not compressed to the highest operating pressure, but to an intermediate level. Then it is cooled down in an intercooler in an isobaric manner or process 2-3. It is then compressed again in the second stage compressor to the highest operating pressure. After that, the compressed air passed through a regenerator. So its temperature increases from 0.4 to 0.5 before entering the combustion chamber. The flue gas from the combustion chamber at 0.6 then expands through the first stage turbine to an intermediate pressure. It is then reheated in an isobaric manner to a higher temperature before expanding again in the second stage turbine. The turbine exhaust then passes through the regenerator before being cooled down in the atmosphere. You can see that the waste heat from the turbine exhaust or process 910 is recovered to heat up the compressed air or process 45. If you compare this complex cycle with a simple Brayton cycle or a cycle in green, which has only one compression and one expansion stage, you can see that the areas enclosed within both cycles are a lot different. The area enclosed within a simple Brayton cycle is much smaller than that of a cycle with intercooling and reheating. It means that you can get more net work from a complex gas turbine cycle with intercooling and reheating schemes when compared to a simple one. The thermal efficiency is also better in the complex cycle as well. Now, let's have a look at the shape of such cycle on a PV diagram. We start from point 1 to point 2, which is an isentropic compression. So this is the first stage compression. Then we have an isobaric cooling, which is a horizontal line from point 2 to point 3. After that, The air is compressed again in the second isentropic compression from point 3 to point 4. The compressed air exiting this stage then passes through the regenerator to absorb heat from the turbine exhaust. The regenerative heat transfer also occurs in an isobaric manner. It is therefore a horizontal line from point 4 to point 5. Next, from point 5 to point 6, it would be heat supply to the combustion chamber by fuel. This process is also an isobaric as well. From point 6 to 7, the flue gas from the combustion chamber undergoes the first isentropic expansion to an intermediate pressure. Then it is reheated in a reheater via an isobaric process. The flue gas temperature increased from 0.7 to 0.8. Then the flue gas is expanded in the second isentropic expansion from 0.8 to 0.9, or the last one in this case. Next, the turbine exhaust passes through the regenerator to recover some amount of waste heat from 0.9 to 0.10 before being discharged to cool down in the atmosphere or in process 10.1. And that has completed the overall cycle. So I guess that you can get a better understanding of the benefit that you could obtain when you apply the regenerative scheme, the intercooling, and the reheating to the gas turbine cycle. You are also able to draw such complex cycle on both TS and PV diagram right now. And that's it for this video, which is the last one in this series. Thank you for watching. See you in the next series on the Weber power cycle. Goodbye.